All right, so if you just want the answer to this question because you searched it up specifically, here it is. But if you want to know a little bit about how to solve the question, I'm going to go over that really quick. So you guys searched up the question. You probably know what it is, but the wording is probably what confused a lot of you. I know it's what confused me, which is why I'm making this video. And so to dissect this problem, I'm sure you've read it a couple of times. You basically have two distributions. I'm going to call the first one x, which has this mean of 78 and a sample size of 30 and a variance of 150, right? We'll call that x. And then we also have distribution y, which is the second one over here, right? And we want to find the probability that the mean of the first sample will exceed that of the second sample by at least 4.8. And so you're probably a bit confused on how to make these distributions interact with each other, but really all that you have to do is have a variable that is just x minus y, right? Because think about it. If you have a variable of x minus y, that's going to be the distribution that you need to get this probability right here, right? And so the rule of this, at least for two normal populations, is that the mean of two normal samples or two independent random samples collected from two normal populations is going to be mu1 minus mu2. This is just something that I think it's a theorem from a book. At least that's what I got in college. So this is just going to be 3, right? And the variance is just going to be the variance of 1 over n1 plus the variance of 2 over n2, and that is going to be 9, right? Just 5 plus 4, which is equal to 9. And so we basically get that x minus y is actually from a normal distribution of mean 3 and variance 9. And we basically just have to find out the probability of getting a value of greater than 4.8 from this sample. So how do you get that? Well, first you have to standard normal it, right? Of course, you can always use a calculator for this and on the internet or something like that, but if you only have the table, which is what I have in college, you first have to calculate the z-score, or the standard normal. And so basically what you get is 4.8 minus 3, right, over the standard deviation, which is 3. Remember, it's a standard deviation, not the variance, so it's the square root of 9. And after that, you get 0.6. That's your z-score. For those of you who are confused on how I got this equation, the equation for the z-score is just going to be your mean that you're trying to find minus the mean of the population. I'll just call that mu over the standard deviation of the population. 3, 4.8, 3. Plug it in, get 0.6. So now we can go to our table and find 0.6. So here's our standard normal table, and we see that 0.6 has a probability of 0.2257. But wait, we're not done, right? Because this is the probability, basically, if we just graph a normal distribution here, between 0.5 and 0.6, right? That's what our normal table is giving us. And so this value here is 0.2257, but we're actually trying to find this value over here. That's greater than 0.6, right? And so what's that probability? Well, remember, this is 0.5 to 0.6, so the rest of the probability here is 0.5. So that's 0.5 plus our 0.2257 that we have over here. And that's just going to be 0.7257. But remember, we're trying to find everything over here, so we're actually subtracting by 1, right? We don't want all this stuff. We want the thing right here. And after that, you get 0.274 approximately. And so yeah, that's how you solve that problem.